Hi, Om here with another video from Oh That Science. Uh, And today's question is, what's the rarest thing ever? Like literally, you can find rare things everywhere, even in Minecraft. A lot of people want to know what the rarest thing is, really. When you ask someone, they're probably going to say gold, platinum, or diamond. Well, those are actually nothing compared to the rarest things ever. So, if you want to know what the rarest thing ever is, we're first gonna need to learn about atomic numbers, mass numbers, and yeah. And before I say what's the rarest thing on Earth, you could be talking about anything. You could be talking about the rarest bicycle on Earth, the rarest ore in Minecraft, the rarest car ever. No. Here's what we're really talking about. When you ask me what's the rarest thing ever, scientifically we can define that by saying what's the rarest element on the Earth. That means anything from the periodic table. And everyone knows the periodic table. It's a table of all the elements in the universe. And we're going to be talking about them today. So, let's start. Let's start about what an atom is. I'm sure lots of you know, but many of you don't either. So let's fill this in, and well, so let's pretend. No, that looks like a black hole. Darn. So let's pretend this blue circle over here is our atom, and then an atom is microscopic. It's extremely small. Atoms is what everything is made out of. Atom is a part of matter, and matter is everything, even you. So here we go. Here's what an atom is made out of. One of the things that an atom is made out of is protons. So, and another one. So you would be writing down a P right here for protons in our circle. So that's done with. Another thing in atom are neutrons. So let's put an N for neutrons. And there. Now the last thing in an atom is electrons. So let's make a different one for electrons, and I'll tell you why later. So there's our three things in our what's in an atom. So here is the important part, which you have to know. In a proton in an atom, which is right here, is always has a positive effect. Let's put a plus for that. An electron in an atom has a negative effect. That's why I made it red. And so that's what you really need to know, that protons positive and electrons are has a negative impact. So we have that covered with. So let's get that erased. And so here our atom is. We still have it. And now let's learn about the atomic number. The atomic number is how many protons there are in an okay, sorry about that. The proton decides what element it is by how many protons there are in an atom. And so let's say my atom over here has 2 protons. Then that depend on the location and all that stuff, which you don't need to really worry about now. So protons decide what element the atom is. Like, I don't know, if I had a certain amount of protons, it could be gold or diamond or whatever. A mass number is another one. So in a mass number, there are protons and there are neutrons. Then let's put a plus right here because you need to have both for a mass number. And what an isotope does is that it makes it rarer than itself. You probably don't get that, like, rarer than itself. What in the world does that mean? Well, that's what I'm about to tell you right now. Here we go. So, an isotope makes it rarer than itself. So, depending on how many protons and neutrons there are, that depends on the isotope, and then that decides what makes it rarer than itself. So here's an example. Let's get rid of this first. So let's talk about. I'm going to show you what it means by making it rarer than itself. That there are different types of atoms. Let's say we have a hydrogen atom right here, and then it's hydrogen atom number 1. Then we need to have other hydrogen atoms, which could be many. So just because I used the hydrogen atom an example for a reason, because hydrogen atoms are extremely important in what we're learning right now. So a hydrogen atom is extremely important because it does a lot for us. A hydrogen atom is one of the most common. So it's not really what we're looking for, but it's one of the most common I can't get this right. A hydrogen atom is one of the most common elements ever. So a hydrogen atom is 99.8% of all different hydrogen atoms in the world. Every single hydrogen atom is hydrogen atom number 1 is the most popular ever. Number 1 is 99% of all hydrogen atoms is making it that also makes it the most common element in the periodic table. Well, technically the most common element ever. It takes up 89.99% of all elements. Every single one is, well, technically 90%. Let's call it 90. Takes up 90% of every single element. So yeah. And then there's 2 types of other hydrogen atoms, deuterium and tritium, which isn't really that important. And then in the periodic table, there over here, all the yellow ones are past number 104 in the periodic table. So there's something weird about number 104 in the periodic table. In the periodic table, there are many, like, as you know, many different elements. But after number 104, every atom has a half-life of less than 28 hours. And you might be wondering, what is a half-life? Well, a half-life is technically when the atom of the element turns into something else. Okay, so let's say we have gold right here. This color doesn't work. let's say we have gold right here. We have I don't know, barely any gold. 1, 2, 3, 4, 5, 6 atoms of gold. So yeah, we have 6 atoms of gold right here, and this gold has a half-life. Let's say the half-life of gold, this isn't really the real half-life, the half-life of our gold is 10 hours. That means in 10 hours, this gold will turn into some other element. Let's say it turns into bronze, which I'm not really sure if this is actually going to happen, but because gold has an extremely long half-life, more than 50 million years, so we're fine about that. But let's say it was 10 hours. In 10 hours, my gold would turn into something else, some other element, which would most probably be less rare. So yeah, we're done with that. And so 28 hours is less. After number 104 on the periodic table, every single element has a half-life of less than 28 hours. That's a bit more than a day. So in the periodic table, there is one element which only has a half-life of 0.89 milliseconds. 0.89 milliseconds. And it's called Anuctium 294. So, and well, my battery's sorry about that. Anuctium 294. It is only at 0.89 milliseconds. That isn't even a second. And so that's just incredibly weird. And so here's where it looks. Here's where it is on the periodic table. Actually marked it out right here. And so it's uno. I'm gonna do the abbreviation. Then 294. So this is. You may be wondering, if it only lasts 0.89 milliseconds, how do we know it's real and how have we observed it? Well, we've only observed about 3 atoms of anuctium. And tell me about it. Atoms are microscopic. Can't even see them with, I don't know, a $50 microscope. You need a really good microscope to see atoms. And we've only observed 3 atoms. And it only has a 0.89 half-life. So they barely observed it. But they know it's real because they have observed it before. So that is just But you might be thinking that anuctium is the rarest element ever. Well, not really. The rarest thing ever so far we have is antimatter. And antimatter is matter, but the opposite. You're like, how does that make sense? Matter is matter is everything. How would there be an opposite of matter? I know that doesn't make any sense to me either when I found out about it. But once I really thought about it and studied it a lot, I found out. So antimatter is the opposite of matter. Remember when I told you before that protons have a positive charge and electrons have a negative charge? Now it's gonna come in importance, because in this protons have the negative charge and neutrons have positive charge, which is extremely complicated. So in that way it is the opposite. And electrons have negative charge. So